60 million years, dinosaurs roamed the Earth, the most successful land animals ever. And then, 65 million years ago, in a matter of moments geologically speaking, they disappeared. It is one of the great mysteries of science. What happened? Was it a catastrophic change in the Earth's climate? A sudden upsurge in volcanic activity? Disease? Or something else altogether? Over 200 years ago, Georges Cuvier established the concept of extinction. Mastodons and other animals such as saber-toothed tigers had gone extinct, he argued, and this idea paved the way for the study of even earlier plants and animals. The fossil record shows individual species of sea and land creatures disappearing at intervals of 5 million years or so. But from time to time there appear to have been more dramatic mass extinctions when virtually all plant and animal groups lost at least some of their numbers. One at the end of the Triassic period, another at the end of the Jurassic, each of which opened the door to a new family of dinosaurs. And then, at the end of the Cretaceous period, came one final extinction that ended the reign of dinosaurs for all time.
These mass extinctions are very special and very terrible events.
Paleontologist Bob Barker.
It's not just one species going extinct. That happens all the time. But usually, you lose a species, a new one evolves, the whole family of species keeps on going. But right now with the great cats, most of the big species are extinct. We're not getting any new ones, and pretty soon all of the great cat family is gone. That's what hit the dinosaurs. The families of dinosaur species died out, no new species were formed, and they were gone. It was a horrendous geological crime. Who is exterminating the great species again and again and again? Let's look at some of the potential criminals.
One good suspect is the environment, a change in the climate of the planet. Throughout the age of the dinosaurs, the average temperature on the Earth was warmer than it is today. If the temperature had risen or fallen drastically, plant life would have withered and animals, especially large animals, would have died out. Glaciers might have brought about that climatic change, the result of shifting continents and shifting winds. Perhaps ice built up at both poles, causing the winter to become incredibly cold, and dinosaurs with no hair or feathers for insulation couldn't sustain their internal temperature. Or perhaps the opposite happened. An explosion of volcanic activity that spewed red-hot volcanic dust into the atmosphere, blotting out the sun's rays. On this theory, dinosaurs would have had no warning of the approaching Holocaust. It would all have happened in a flash.
Maybe something out there from the cosmos smacked into the Earth, sending up a plume of dust, blotting out the sun's heat, and freezing the dinosaurs to death. Something huge, something full of energy, an asteroid.
The suggestion that an asteroid impact killed the dinosaurs dates from 1980. It came from a team of Berkeley scientists led by geologist Walter Alvarez.
Back in the 1970s, I was working in Italy with a group of other geologists and geophysicists on a project that had nothing to do with the dinosaurs. We were dating the reversals of the Earth's magnetic field that were recorded in a series of rocks that had been deposited on the floor of the ocean, one after the other like this, sort of made a book of Earth history. And while we were doing that work, we kept walking past this very intriguing layer of clay, and so I cut out a piece and brought it home. You can really see what's going on here. This layer is the top bed of the Cretaceous. This corresponds in time to the last times that the dinosaurs were alive. And this bed up in here is the first bed of the Tertiary, which is after the dinosaur extinction was over. And in between them is this layer of sort of red and green clay. And it seemed as if that had to be telling us something. So I cut out this piece of rock and brought it home, and not only was it interesting to me, I showed it to my father. It was interesting to him, too, and we decided, let's see if we can find out what is responsible for that clay.
Walter's late father, Nobel Prize-winning physicist Luis Alvarez, started by trying to date the clay layer to see how long it took to accumulate. What he found was the first clue to the impact theory. The clay was found to contain huge amounts of cosmic dust, specifically a platinum-like metal called iridium. Alvarez knew that while iridium is rare on the surface of the Earth, it is abundant in asteroids and comets. It was evidence, says Walter Alvarez, that a giant asteroid collided with the Earth.
What we finally came up with was the idea that dust and droplets of impact melt that had been thrown out of the atmosphere and dispersed all over the planet would make it so dark that photosynthesis would stop and the food chains would collapse and the extinctions would be the result of starvation when the food supply ran out.
Within hours of the impact, according to the Alvarez group, a great cloud of dust began to envelop the Earth. Beneath the cloud, day turned to a permanent night. The food supply dried up. Dinosaurs and millions of other creatures perished in the cold and the dark. Of a direct hit on planet Earth is chilling and enthralling. But is it true? Our investigation begins in Makoshika State Park in southern Montana. The rocks here are a record of the Earth as it was just before the dinosaurs disappeared.
We're going to line you up on the outcrops to do the survey, and you'll be about 10 or 15 feet apart, and you're going to walk slowly over the outcrops, looking for fossils. When you find...
Diane Gabriel and David Fastovsky have brought these volunteers to Makoshika to count bones. With their help, they hope to settle a vexing question. Was the dinosaurs' demise sudden, as the impact hypothesis suggests, or did they die out gradually over the course of several million years?
So let's walk over that way.
There's never been a good answer to the question, because the number of dinosaurs alive at any given time has never been properly calculated. Here, Fastovsky and Gabriel decided to count every single bone.
Okay, everyone in position. Let's go. Remember to stay in line as much as possible.
They picked this site because the rocks here are filled with bones from the very end of the dinosaurs' reign, the last 3 million years of the period of Earth history known as the Cretaceous. The boundary between the Cretaceous and the Tertiary period that followed is marked here by a blue band running through the rock. Above the boundary there are no remains of dinosaurs to be found, but below it they are everywhere. All you need is patience and a pair of eyes sharp enough to spot bone half buried in the rock.